Okay, for number one, uh, which scatter plot could have a trend line whose equation is y equals x plus 4? So the slope is 1x. Okay, so slope is a positive 1. So let's go ahead and take a look here. If I were to draw a trend line through A, it's going down, and if I would draw a trend line through B, it looks like it's also going down. So it's not A and it's not B. Okay, so the positive slopes for that positive 1 slope would be one of these two. Okay, positive slopes. Okay, so the slope here is 1 over 1. Okay, and the y-intercept is 4. So since it's a positive 1 over 1, let's go up 1, right 1 from 4 on these two and see which trend line matches the best. So here's 4, and if I go up 1, right 1, up 1, right 1, let me zoom in so you can see what that looks like. Okay, so I'm just going up 1, right 1, up 1, right 1. It's hitting every corner. Okay, after you start from 4. Okay, and that's where the trend line looks in comparison to the points. Now let's try it for this one. There's 4. Okay, up 1, right 1. So let's draw it right through the point, right through the. Okay, so if I go up 1, right 1, going through every corner there, it looks like it matches better for D. Okay, so number 1 is option D. Number 2, it says from which graph from question 1 has a strong negative? Okay, so if you look, well, negative, right, has a strong negative. So it's not C or D, it's A or B. And B, the points make more of a line with each other. In A, it's negative, but they're a little more scattered. Okay, the points in B make more of a line, right? So that's how you determine something is strong. Okay, it makes more of a line. So this one is B. Number 3, for the data shown in the scatter plot below, which point is an outlier? Okay, so there's our outlier. Okay, so x is 1, y is 3. Okay, all right, so for number 4, Marisol graphed a scatter plot for the number of hours she rode her bicycle and the distance traveled. Okay, so x is the hours, y is the distance traveled. She knew the trend line and calculated the equation to be y equals 10x plus 4. What is the predicted distance Marisol rode her bike if she rode it for 2.5 hours? So 2.5 hours, hours is x. Okay, so this is our x. So we're going to put it in here. Y equals 10 times 2.5, 2.5 plus 4. Okay, so I'm just going to type that in. It's all on the same side of the equal sign. So I have 10 times 2.5 plus 4. 10 times 2.5 plus 4, and that gives me 29. Okay, so here y is 29. That's option C. Okay, all right, so for 5 through 7, there's the table that goes with each of those. All right, so what is the percentage of rural debit card users? So it wants the percentage of everything, okay? And what it wants is the percentage of rural debit card users. Rural debit card users, we have 18 rural debit card users, okay? And the total is 100, right? So this is 18 divided by 100, right? Rural and debit card users, there's 18 of them out of 100. This gives you divide it, you get 0.18. Okay, 0.18 is 18%. Okay. And when we get to number 7, we'll look at the difference between the wording of number 5 and the wording of number 7. Okay. All right, number 6, what is the percentage of rural customers? All right, so the percentage of rural customers, there's 31 rural customers. Right? 13 that use credit, 18 that use debit, but there's 31 rural customers. And what's the total? There's 100 in the survey. Okay, so this is 31 out of 100. That gives you 0.31 times 100 gives you 31%. Okay. All right. Number 7. Let's compare the difference between 7 and 5. Okay. 7 says what percentage of rural customers? Of rural customers. So it specifies the of. Okay. So it's 31 rural customers. Okay. So of. So that's our denominator. What percentage of rural customers use debit cards? There's 18 that use debit cards. Okay. So this is 18 divided by 31. And 18 divided by 31, that gives me 0.58. Okay, so this is 0.58, and that's 58%. So notice in 5, rural debit card users, it wanted that percentage of rural debit card users, so it's 18. This one said of the rural customers. Okay, what percent use debit cards? All right. For this one, okay, so here's what the points should look like. Okay, so I've gone ahead and grafted these in case you missed this. 30-60 is right there. Okay, 60-30 is right there. 90-30 is right there. Okay, 60-40 is right there. 20-80 is right there, and 80-20 is right there. Okay, so that's what your points should look like for that table. Okay, and I went ahead and drew a line of best fit. It should go through the middle of those points. Okay, and so that's what that graph should look like just before number 8. All right, so for number 8, it says choose an equation for the trend line. All right, so notice our trend line's going down. It should be negative slope. Okay, so since it should be a negative slope, let's look at A and D. Those have positive slopes, right? A has a slope of 1/1 positive. D has a slope of 2/1 positive. So it's not A and it's not D. It's one of these two. Okay. Now let's look at the y-intercept of our trend line. It's between 80 and 85. Okay, or it should be, right? Somewhere around there. Right? The y-intercept for B is 20. We know it's not B then. Right? The y-intercept should be about 85. Okay. Number 9. What type of association does the trend line show? And it's going down. The slope of the trend line is going down, so that's a negative correlation. Okay, and then number 10, predict the amount of time a student will use the internet if she uses the phone for 45 minutes. So if you notice the phone time it gives you Y. Okay, it wants to know what X is. Okay, predict the amount of time a student will use the internet. It wants to know the X. Okay. All right. So it gives us Y here. Y is 45. So when Y is 45, there's 40, there's 50. So right about there. It looks like from our trend line, when Y is 45, X is about 55. So let's choose a number closest to 55. Well, 55 is right on there. Okay, so you want to choose a number closest. Sometimes it's right on there. Sometimes you got to choose something close. All right, so number 11. All right, so here's another two-way table. Okay, how many lunches did the restaurant serve over the weekend? Well, over the weekend, lunches, so that's Saturday and Sunday over the weekend, okay? So it served 78 lunches, right? Just 42 plus 36. Okay, so this is a 42 plus 36. Or 78 lunches, okay? So 78 is what we want there. Alright, for number 12, what is the frequency of Sunday lunches? So it wants Sunday lunches. Okay, so it wants 36 out of 150. Okay, what is the overall frequency? Okay, so it's going to be 150 is our denominator of Sunday lunches. So it's 36. Okay, so for number 12, 36 over 150, I'll do 36 divided by 150, and I get 0.24. Okay, so I get 0.24 for 0.24, that's times 100, 24%. Okay. All right, number 13 says, what is the frequency of dinners over the weekend? Okay, so dinners, there are 72 dinners. Okay, 72. And over the weekend, well, there's all of these are over the weekend. Okay, so all of these are over the weekend. So, right, you have Saturday, there's 100 on Saturday. There is 50, right, on Sunday. So those are, the total is 150. Okay, so what is the frequency of dinners over the weekend? So this is 72 over 150. Okay, so for number 13. So 72, we'll do 72 divided by 150. That gives us 48.48. Okay, so this is 0.48, and 0.48 is 48%. Okay, so we looked at dinners. There are 72 dinners. And how many lunches and dinners were there over the weekend? There was 150 total. Okay, all right, number 14. So what is the equation for the line of best fit? Notice all of these are in y equals mx plus b form. Okay, so all of these are in y equals mx plus b form. So let's go ahead. All the slopes are different. Okay, so let's go ahead and find the slope, and we should be able to get the y-intercept. We should be able to choose the line from there because all these slopes are different. Okay, notice the y is getting smaller. It's decreasing while x is getting bigger. Okay, so that means the slope needs to be negative, right? Y is getting smaller. Okay, so since y is getting smaller, right, it's not A and it's not C, right? Y is getting smaller, right? So this needs to be negative. Okay, this has to be negative. Okay, y getting smaller. I want you to write that down. Okay, so now we need to find the slope. Okay, so that's the change in y over the change in x. Okay, so we need to find change in y over change in x. Alright, so that'll give us our m. M equals change in y over change in x. Alright, so let's find the change in y over change in x. Change in y is 1. Change in x is 2, right? From 21 to 20, that's a difference of 1. It changed 1. From 8 to 10, that's a difference of 2. It changed 2. So change in y is 1, change in x is 2. So our slope is going to be a negative 1 over 2. Okay? And of these two, right, the negative 1 over 2 one is right here. Okay? Alright, let's look at number 15. So for this, there's a couple of different ways you can do it, and I want you to write both ways. 2 to the 7th over 2 to the 4th. So one way is I know the base is the same. Okay? Since the base is the same, the base is going to be 2. Okay? Now, I have a 7 minus 4 because it's division. 7 minus 4 is 3, so it's 2 to the 3rd. Okay? So 2 to the 3rd, that's 2 times 2 times 2, that's 8. Okay? Alright, now, the other way of looking at it is 2 7 times at the top. 1, 2, 3, 4, 5, 6, 7. 2 4 times at the bottom. 2, 1, 2, 3, 4. Okay, so those cancel each other out. Look what I have. 2 times 2 times 2. Right? That gives me 8. Okay, so it's this one. Okay. Alright, number 16. What is the solution for 8 to the what is the solution for the equation x to the 3rd equals 8? Alright, so let's do one that's incorrect and one that's correct. Okay, so here's one that's incorrect for B, for example. X to the 3rd. Okay, so let's say 4 is x. Okay, 4 is x. So 4 times 4 times 4. Well, 4 times 4 is 16. 16 times 4 is 64. That's not correct. Okay, so let's try this one. X to the 3rd, say x is 2. 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. This is the one we want, right? X to the third equals 8. Alright, for number 17, it says, is this graph a function? And we do the vertical line test. And look here, if I choose this line right there, look, it hits 2 points. Okay, if I choose this line right here, look, it also hits 2 points. There's several times where I can draw a line, a vertical line where it hits 2 points. Right? That means at each of these values of x's, there's 2 y's. Okay, so that's not a function. It doesn't pass the vertical line test. Okay, so number 18, find the product. Alright, so for the product here, that means multiply. It sets it up for you. There's no sign in between the parentheses, so it's a multiplication. I need to write this, okay, as a scientific notation. Okay, so this is 3. I need to move the decimal back 3 spaces, right? I need to move it back 3 spaces, so this is 3 times 10 to the negative 3. Okay, because this number is less than 1. It's 0 point something, so that's why it's a negative 3 exponent. Okay, all right. So now I have this times 5 times 10 to the 7. So I have 3 times 5. 3 times 5 is 15. Negative 3 plus 7. Okay, so for multiplication I add. So negative 3 plus 7. I'll write it down. Negative 3 plus 7 is 4. Okay, so this is times 10 to the 4th. Okay, alright, so notice here, all these, besides 15, I know it's not 15 because our answer is 15 times 10 to the 4th, so I know it's not that one. Alright, so I need to put this in scientific notation. I need to put the decimal between the 1 and the 5. 1.5, this got smaller, so this has to get bigger, times 10 to the 5th. 1.5 times 10 to the 5th. Okay. Alright, so for number 9, I have this. So notice all these bases are 3, so I will have a 3 base here, and I can add the exponents. This is all multiplication. Okay, so what I'm going to do is negative 5 plus 0 plus 8. Negative 5 plus 0 plus 8. You can use your calculator on this if you need, right? Negative 5 plus 0 plus 8, that's 3. Okay, so this is 3 times 10 to the 3rd. Okay, so that's our new exponent. And 3 times 10 to the 3rd, that is 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. Okay, so that's option C. Okay. Alright, so for the next one, number 20, the mass of Mars is 6 times 10 to the 21st. The mass of Venus is 5 times 10 to the 24th. Okay? Which statement is true? First, notice that all the options are saying how many times bigger one is than the other. So first, we have to decide which one is bigger. Okay? Venus has an exponent of 24. Mars has an exponent of 23. Venus is bigger. Okay, they're both in scientific notation. Venus is bigger. So the ones that say Mars is bigger, A and C, you cross off. Okay. Alright, so now for ones like this, okay, so write this down. I'm going to cut off number 9 here. Alright, so ones like this, we have to divide, right? How many times bigger is one thing than the other? That means we have to divide. Okay, so Venus is the bigger one. So Venus is 5 times 10 to the 24th. And Mars is going to go in the denominator. Okay, so it's a smaller one, 6 times 10 to the 23rd. Okay, so 5 divided by 6. Notice our options are 10 and 100. Okay, 5 divided by 6, that's about 1. Okay, 6 goes into 5 about 1 time. Okay, they're almost the same number. Okay, 6 divided by 5, or 5 divided by 6, about 1. And then I subtract the exponents. 24 minus 23. 24 minus 23 is 1. So my exponent times 10 to the 1. This is 1 times 10 to the 1. That's just 1 times 10. 1 times 10 is 10. Okay? So Venus is approximately 10 times bigger than Mars. Okay? Alright, for number 21, which table shows the relationship between X and Y? Okay, so let me do one that is incorrect, and then I'll do one that is correct. So, Y is 2 more than 3 times X. Okay, so this is 3 times, and then 2 more. So this is times, and then this is plus. Okay, alright, so let's test this. X, 3 times 1 plus 2. 3 times 1 plus 2. 3 times 1 is 3. Plus 2, well, that equals 5. Y needs to be 5. Okay? That one's not correct. It has to work for all of them. Okay? Alright, so let's try this one. Okay? So this is, again, more. That means plus. And then we have the times here. 2 times x. Okay? So let's test it. 2 times x. 2 times 1 plus 1. 2 times 1 is 2, plus 1 is 3. Look where y is 3. Okay? So 2 times again. 2 times 2. 2 times x. This is 2. 2 times 2 plus 1. 2 times 2 is 4, plus 1 is 5. Look, the x is 5. Okay? Now let's do another one. 2 times x is 3. 2 times 3 plus 1. 2 times 3 is 6, plus 1 is 7. Okay? It works for all of them. This is the one. Alright, number 22. Choose the solution to the equation. Okay, so for this one, I'm going to do it in a couple of ways. Okay, first I'm going to solve it, and then I'm going to show you how to plug it in. Okay. So first, let me see here. So this is 3. Okay, so let's. Okay, so let's go ahead and solve it. All right, so I need to distribute. Okay, there's a parenthesis there, so this goes like this: 2 times x. 2 times 1 is 2, minus 7 equals 1. Okay, so I just bring down the 7. I have some like terms here. Okay, 2 minus 7, 2x plus 2. 2 minus 7 is negative 5. So I'll put a minus 5 equals 1. Now I've got to solve this equation. Okay? So I have plus 5 plus 5. So I have 2x equals 6. So here I have 2x equals 6. Now I've got to divide by 2. X equals 3. Okay, so there's my answer. So let's test one here that isn't the answer. Suppose you came to 6, okay, and you plugged in 2 parentheses. All right, so suppose you chose this one, 6. 6 plus 1 minus 7 equals 1. 6 plus 1 is 7. 2 times 7 minus 7 equals 1. Well, 2 times 7 is 14. 14 minus 7 is 7. 7 equals 1. That's not it. We know it's not that one. Okay. Alright, now we know the answer is 3, so let's plug in 3. Okay. So you have this. 2 times 3 plus 1 minus 7 equals 1. 3 plus 1 is 4, so you have 2 times 4 minus 7 equals 1. 2 times 4 is 8. 8 minus 7 equals 1. And 8 minus 7 is 1. Okay, so this is the one you want. Okay, alright. Number 23. Which equation has no solution? Okay. Alright, so no solution. Let's go ahead and distribute. So for the first one, let's distribute this one. 2 times x is 2x. 2 times 5 is 10. So both sides, they have the exact same thing. This is infinite solutions. right? The x is exactly the same, and so is the constant. The x term and the constant are exactly the same. So we want no solution. So this is no. Okay. All right. So let's do the next one. Let's distribute. Okay. 3 times x is 3x. 3 times 4 is 12. Okay. So on the left side you have a 4x. On the right side you have a 3x. Okay, so this is going to have one solution. The x's are not exactly the same. There's not a special answer for this one. Right? The x terms are not the same. There's no special answer. It's not infinite solution. It's not no solutions. This is going to have an answer. You can solve this x. So it's not this one. Okay. The next one. Let's go ahead and distribute in. 7 times x. 7 times x is 7x. 7 times negative 3 is negative 21. This is the one where, look, on the left side there's a 7x. The right side there's a 7x. Okay? You're going to get a special answer here. The left side has nothing else other than the 7x. The right side has 21, or negative 21. Okay? This is your no solution. Okay? The one at the bottom, okay, is 6 times 2 plus 5 is 3. 2 plus 3 is 5. Okay? So this is x equals 6 times 5. This one is x equals to 30. Okay, so that's not it either. We know the answer. We just have to do the order of operations. Okay? All right. So for number 24, which of these is likely to be irrational? Okay. So for the irrational numbers, right, there are 3 visual indicators. Okay, so for irrational numbers, so I want you to write this. Irrational. Okay. The first visual indicator is the dot, dot, dot. The second visual indicator is the square root of an imperfect square. Okay. And then the third one is pi. Okay. Nothing else. Okay. Just those 3 visual indicators. Alright. So let's take a look at these. Okay. So obviously this one repeats. The D one. Okay. This is 6.072 with a line. That's how that's normally written. Okay? Not one of the visual indicators of the irrational number. Look at C. C also repeats 45, 45, 45. This is 9.45 with a line over. Okay? So with the line, with the repeating, okay, non-terminating and repeating one, right, those aren't irrational. We can make fractions out of that. Okay? Look at B. B actually repeats. If you look, 142857, 142857. It's repeating, and so it's another one. This one is written as 3.142857 with a line over it. Okay? This is the one that doesn't repeat. There's no pattern here. This is a non-terminating, non-repeating decimal expansion. This would be written, right? There's nothing that repeats here. You can't see a pattern that it goes over and over again. This one would be written to 7.19 dot, dot, dot. Okay, so this is the irrational one. That's the non-terminating, non-repeating one. Okay. Alright, so number 25. A line intersects the y-axis at a coordinate of 5. The y-axis at a coordinate. So your b here equals 5. Okay. The line passes through the point 1, 3. So remember, this is x and y. Which equation describes the line? Alright, so our y-intercept is 5. So let's look at these equations. The only one that doesn't have a y-intercept of 5 is D. All of these are possibilities. Okay, so let's try the ones that don't have a fraction first. Okay, actually, let's try the ones that don't have a fraction first. First, let's try C. Okay, all right. So I know x is 1. Okay, so x is 1. So 4 times 1 plus 5. Okay, and this should give us y. Well, 4 times 1 is 4. 4 plus 5 is 9. Okay? Our y is 3. Okay? So this says 3 equals 9. That doesn't work. It's not this one. Okay? Let's try the next one. Y equals, x is 1. So negative 2 times 1 plus 5. Alright, so negative 2 times 1 is negative 2. You can type this into your calculator if you want. Negative 2 times 1 is negative 2. Negative 2 plus 5 is 3. This is 3. Look, our y also is 3. This is your answer. Okay. Alright, and then number 26. Number 26, square root of 26. So for the square root of 26, the next lowest perfect square is the square root of 25. The next highest is the square root of 36. This is a 5 and a 6. Okay? Now this is a 36, so you can't see that. Okay? So I know it's going to be 5 point something. Okay? So it's not this, and it's not that. It's really close to the smaller 25. Okay? So our options are 0.1, 0.2, 0.3, and 0.4. It's really close, so it's going to be 5